Welcome students. This video is the part of 4th and School digital learning program. Today we discuss about numerical based on Nerns'T equation. In our previous lecture we discussed about the Nerns'T equation. Okay, today we discuss about the questions which are based on this Nerns'T equation. In examination there is 3 mark question which always comes. So you see the question on your screen. Calculate standard cell potential of a galvanic cell in which following reactions take place. You see the reaction here. If you see this reaction, then you find that chromium is undergo oxidation and become converted into chromium tripositive cation, while this cadmium 2 plus ion undergo reduction and gives cadmium. And the standard reduction potential will also given here. The standard reduction potential for chromium is 0.74 volt, for cadmium is minus 0.40 volt. Now, how we find this EMF or standard cell potential? You can see here we have a common formula for the standard cell potential, that is redox, A red minus E ox. Then we have to write reduction potential of reduction of cell, and the reduction is carried out in cadmium. So what about the standard reduction potential of cadmium is minus 0.40. So we write it as such: minus 0.40 minus 0.74. So we got standard cell potential, that is plus 0.34 volt. That positive sign indicate that that positive sign indicate that the reaction is feasible and cell exists, and this cell act as a galvanic cell or electrochemical type of cell. Okay, and the output voltage of this cell is 0.34 volt. So we solve half of the question in such a way. Now additionally we can also solve standard change in this enthalpy also. Okay, is not a part of this question, but additionally if you want to solve this del G naught value, then easily we find with the help of this formula, because we already have the value of E naught cell. By putting this value on in this formula, del G naught is equal to minus NF E naught cell. We got minus 196.83 kilojoule per. Okay, so this is a question which is based on uh, standard cell potential. Come to the next, the question which is purely based on Nernst equation. So what about the Nernst equation? This is your basic formula for the Nernst equation, that shown in a blue caption. You can see here, E cell is equal to E naught cell minus 0.0591 divided by M log product concentration upon reactant concentration. Okay. Now on the product side, we can see here magnesium is yes, you can see here it is a cell expression, and these two vertical parallel lines represent salt bridge, and whatever is written on the left side is called oxidation half cell, and whatever is written on the left side is called reduction half cell. So you have to write red minus ox, that means reduction is always considered as a oxidation half cell is always considered as a product. So you have to write here Mg2 plus. Why we do not include this magnesium solid? Because in equilibrium expression for Kc, we take magnesium concentration as a unity because its physical state is solid. Okay, so magnesium on a product side and reactant as a Cu2 plus. By putting these concentration at this ion concentration. Finally got log 10, and the value of log 10 is 1. By dividing 2 with 0.0591 by 2, we got this expression. So this is all are about the question which based on Nerns'T equation. Finally we got EMF, that is 2.67 volt. Okay, so these are the questions which are based on Nerns'T equation. Come to the next. Some other formulas that you will learn in your uh, class 10, and some of the are the new for the newcomers. You can see here. So these are the quantity, these are the units, and these are the formulas. So you have to learn each and every formula. Okay, so first you see resistance, that is represented by capital R, and the unit of resistance in which it measure, that is ohm. The sign of ohm is like that. Formula is rho L upon A. It is a formula. Rho is resistivity, L is the length of wire, A is the cross section area. A similar conductance is a reciprocal of resistance, so obviously its unit is ohm inverse or ohm inverse. What about the conductivity? Conductivity unit is 1 upon rho, is a reciprocal of resistivity, is called conductivity, and the unit of rho is Simon. The unit of rho is Simon. Okay, what about the cell constant? Its unit is meter inverse. You can see here. As you can see here, the formula for the conductivity is Simon. Simon, that means ohm inverse and meter inverse. Okay, what about the cell constant? Cell constant is the ratio of length of wire upon cross section area. What about molar conductivity? That is Simon centimeter square mole inverse. Okay, now we see the types of conductivity. So basically conductivity is of two types. One is electric or electronic conductivity, and another is ionic conductivity. Electric conductivity is what is a conductivity that present in a metallic wire. And what about this ionic conductivity? It is a conductivity which is present in ionic solution. Okay. In case of electric conductivity, there is a charge carrier which are free electrons, while in ionic conductivity, the charge carriers are free ions. They may be cations or anions. The types of ionic conductivity is of two. One is molar ionic conductivity and another is equivalent ionic conductivity. In this chapter, we talk about only molar ionic conductivity. Now, the factors which affect the ionic conductivity, these are concentration, mobility of the ions, that means movement of the ions, viscosity of the solution. Okay. Now, nature of electrolyte, whether the electrolyte is polar or non-polar. Okay. Whether the electrolyte is strong or weak, and the temperature. So these are the factors which affect the ionic conductivity. As we increase the temperature, ionic conductivity will also increases. Ionic conductivity is measured is in great extent in case of uh, polar electrolytes. In a highly viscous solution, ionic conductivity measurement is very low. In case of mobility, if ions show great mobility, then it will also result into high ionic conductivity. What about the concentration? As the concentration increases, then ionic conductivity will decreases. Okay, because ionic conductivity is inversely proportional to concentration and directly proportional to dilution. Next, the effect of concentration on the conductivity. So what we see, kappa, that means conductivity, is directly proportional to concentration. As we increase the conductivity, as we increase the concentration, conductivity will increases. What is the reason behind it? Because as we increase the concentration, we increase the number of ions per unit volume. If we increase the number of ions, then we increase the charge carrier. Because of that, ionic conductivity will increases. Okay. Now, what about the molar conductivity? So the molar conductivity show contrast effect towards the concentration. As you increase the concentration, molar conductivity decreases. The reason is that as you increase the concentration, inter-ionic interactions will increases, due to which conductivity decreases. Okay. On and the reverse, on dilution, inter-ionic interaction decreases, so conductivity increases. Okay. And the variation of molar conductivity with concentration is best explained by Debye-Heckel-Onsager equation that states as lambda m is equal to lambda m naught minus a. A is a constant and its value vary the types of electrolytes. This is a concentration that is always in molarity, okay, to the power that is minus half. So if we plot a graph in between molar conductivity and concentration of strong and weak electrolyte, acetic acid is a weak electrolyte while KCl is a strong electrolyte. Okay. So you see the variation in the graph, but this both the curves represent that molar conductivity is inversely proportional to concentration. As we increase the concentration, molar conductivity of both, whether it is a strong electrolyte or weak electrolyte, is decreases, is going on decreasing. Okay. But the decreasing pattern is different. KCl is decreases by following straight curve, while acetic acid show the sigmoid type of curve or J-shaped curve. You can see here. If we draw this line, you see there is an increment of concentration, and in the reverse direction there is an increase in dilution. So if the concentration is nearly to the zero, it show infinite dilution. So if we draw this curve further, then what we got? We got a line that touch the y-axis, and the point of touching is called lambda m naught, that is limiting molar conductivity. That point indicate the lambda m naught, that is limiting molar conductivity. Okay. So we can directly obtain this limiting molar conductivity for a strong electrolyte by using this Debye-Heckel-Onsager equation. But for the weak electrolyte, we are unable to achieve this limiting molar conductivity because this line never intersect this y-axis. Okay. So for calculation of this limiting molar conductivity of weak electrolyte, we use Color's law that we include in our next lecture. Okay. So this graph represents the variation of molar conductivity with concentration. Okay. Now this is all about today lecture. There is a worksheet. You have to give the each and every. You have to solve each and every question. I will also provide the answers. You can see here. What is the limiting molar conductivity? Give its unit. So definition of limiting molar conductivity is it is a molar conductivity at infinite dilution. You can see here that point show the infinite dilution. At that point, concentration is just tends to zero. That's why it's called infinite dilution point. The unit is the same as the unit of molar conductivity, that is Simon centimeter square. mole inverse. There is a Simon centimeter square mole inverse. There is a correction. Simon centimeter square mole inverse. Okay. Yes. Now, second question: give reason molar conductivity increase with the dilution due to decrease in intra-ionic interactions. Okay. Now, question number third: are the charge carried in metallic wire? Since the conductivity type of conductivity which present in metallic wire is electronic conductivity, and for electronic conductivity we require free electrons. So free electrons are the charge carrier in metallic wire. Okay. While in case of ionic solution which show ionic type of conductivity, so the charge carriers must be free electrons. Now the question number fifth: mention the factors which affect the ionic conductivity. So there are four factors. One is viscosity, mobility of ions, temperature, and nature of electrode. So this is all about today's lecture. Okay. If you got some difficulty, you can ask in our comment section. Have a nice day. Goodbye.